Well, hey friend, you've made it to part 3, so high five a stranger and then keep going. In this episode, I want us to really start to learn how Symfony works under the hood. We'll learn what a service is, find out more about the core Symfony services, and create a few of our own. In Doctrine, we'll create some many-to-one and many-to-many relationships. We'll also talk about lifecycle callbacks and event listeners. And there's a lot more that we're hiding in between all of these topics. And you've been coding with me, right? If you have, you should now feel comfortable creating new classes, routes, and templates. You're going to kill that first project. So when you see new concepts, stop the video, investigate, play with them, and then keep going. Ultimately, looking inside some of Symfony's own classes is a great way to get even more comfortable. Okay, let's roll. Right now, if I create an event, there's no database link back to my user. We don't know which user created each event. To fix this, we need to create a one-to-many relationship from user to event. In the database, this will mean a user ID foreign key column to the Yoda event table. In Doctrine, relationships are handled by creating links between objects. Start by creating an owner property inside event. For normal fields, we use the @ORM column annotation. But for relationships, we use @ORM many-to-one, @ORM many-to-many, or @ORM one-to-many. This is a many-to-one relationship because many events may have the same one user. I'll talk about the other two relationships later. Add the @ORM many-to-one relationship and pass in the entity that forms the other side. Next, get the getter and setter for the new property. Notice that when we call setOwner, we'll pass it an actual user object, not the ID of a user. But when you save an event, Doctrine will use the owner's ID value to populate an owner ID column on the Yoda event table. So we link objects to objects in PHP, and Doctrine takes care of setting the foreign key ID value for us. If you're newer to an ORM, this is one of the toughest things to understand about Doctrine. How can we update our database with the new column and foreign key? Why, with the Doctrine schema update command, of course. I'll dump the SQL to the terminal first to see it. As expected, the SQL that's generated will add a new owner ID field to Yoda event along with the foreign key constraint. Since I'm feeling fancy, let's configure a few things. Whenever you have a many-to-one annotation, you can optionally add an @ORM join column annotation to control some database options. To add a database level onDelete cascade behavior, add the onDelete option. Now let's run the Doctrine schema update command again. The SQL tells us that this actually recreates the foreign key with an onDelete behavior. So if we delete a user, the database will automatically delete all rows in the Yoda event table that link to that user and ship them off into hyperspace. Another common option is cascade on the actual many-to-one part. This is like onDelete, but in the opposite direction. With this, if we delete an event, it will cascade the remove onto the owner. In other words, if I delete an event, it will also delete the user who is the owner. Run Doctrine schema update again. Now, it doesn't want to change our database at all. Unlike onDelete, this behavior is enforced entirely by Doctrine and PHP, not in the database layer. Remove the cascade option because it's dangerous in our situation. If we delete an event, we definitely don't want that to delete the event's owner. Darth would be so angry. Time to put our shiny relationship to the test. When a new event object is created, let's associate it with the user object for whoever is logged in. To complete the link, just call setOwner on the event and pass it the whole user object. Yep, that's it. When we save the event, Doctrine will automatically grab the ID of the user object and place it on the owner ID field. Time to test. Log in as Wayne. Remember, he has role admin, which also means he has role event create because of the role hierarchy section in security.yaml. Now fill in some basic data and submit it. To see the result, use the Query tool to list the events. Sure enough, our newest event is linked back to our user. Winning! Let's update the fixtures so that each event has an owner. We have two fixture classes, one that loads events and one that loads users. Start in the Load Users class. Now that events depend on users, we'll want this fixture class to be executed before the events class. To force this, implement a new interface called Ordered Fixture Interface. This requires one method called getOrder. Let's return 10. Head over to Load Events and make the same change, except returning 20 so that the class is run second. Now we just need to get our new user objects inside Load Events. Doctrine Fixtures Bundle has a standard way of sharing data between fixtures, but a much easier way is just to query for our Wayne user. All we need to do now is call setOwner on both events so that it looks like Wayne created them. Okay, reload the fixtures. Now use App Console to check that each event has an owner. Now that every event has an owner, let's prevent that meddling Darth from editing any events that he didn't create. This should be pretty easy. If the current logged-in user object doesn't match the event's owner, we'll just deny access. And remember, you can deny access anywhere in your app just by throwing the special access denied exception. Since we'll need the same security logic in edit action, update action, and delete action, let's create a private function called enforce owner security that holds it. It's now pretty simple to prevent Darth from doing things with events he didn't create. Just call this function from edit action, update action, and delete action. Okay, log in as Darth and try to edit an event. Denied. In the production environment, the user will see a 403 page that you can customize. And in a few minutes, we'll show you how. Now that Darth can only edit an event if he created it, add an if statement around the edit link that hides it from all other users. Remember that this works because app.user gives us the user object for whoever is logged in. Getting the security.context service requires too much typing. So let's make some improvements so we can get things done faster. Create a new class called Controller inside the event bundle and make this class extend Symfony's standard base controller. But watch out! Both classes are called Controller, so we need to alias Symfony's class to base controller. Inside this class, create a function that returns the security context from the service container. head back to Event Controller. Right now, this extends Symfony's controller, which means that we get access to all of its shortcuts. Remove the use statement for Symfony's controller and replace it with the use statement for our fancy controller class. Now we can access all of Symfony's shortcut methods and the new getSecurityContext method we created. And actually, we don't even need the use statement because this class lives in the same namespace as the new controller class. Okay, let's use the new getSecurityContext method to shorten things. And even though we're not really using its page, remove the use statement in default controller as well so that we're using the new class. Change the use statements in both Register Controller and Security Controller. In Register Controller, we can also take advantage of the new shortcut. These controllers do need to have a use statement because they don't live in the same namespace as the new controller class. Now that all of our controllers extend our controller class, we can add whatever shortcut functions we want here. For example, if we need to check our event owner security in another controller, we could just move that function into controller and make it public. With the base controller, we can give ourselves shortcuts to develop faster and faster. Inside Register Controller, my IDE recognizes the setToken method on the security context automatically. Actually, this only works because I'm using an awesome Symfony 2 plugin for PHP Storm. The getSecurityContext method doesn't have any PHP doc, so any other editor will have no idea what type of object this method returns. To fix this, and because PHP doc is a good practice, let's add some to our new method. Because of the Symfony 2 plugin, the @return tag was filled in automatically. That's awesome! But if we hadn't, we could figure out what type of object security.context is by using the container debug console command. If you use PHP Storm, install the Symfony plugin. If not, rely on this console command to help you find out more about a service. It's like you read my mind. Now is a perfect time to rerun the test suite to make sure we haven't broken anything. I know, we're missing tests for some important parts, like event creation, but it's better than nothing. But first, update your test database for our latest schema changes. We need this because we configured our project in episode 2 to use an entirely different database for testing. Earlier, we gave every event an owner. This was our first doctrine relationship, a many-to-one from event to user. This lets us do things like call event getOwner. Let's use this to print the owner of an event. But what about the opposite direction? Can we start with a user object and call getEvents to get all the event objects the user has created? Open up the play script we made in episode 1 to test this out. Clear out all the code below the setup. Then query for a user object and call getEvents on it. Now run the script. It blows up! This shouldn't surprise us. The user object is a plain PHP object, and we've never added a getEvents method to it. We can do this, and it's not hard, but it can be tricky to understand. It involves 3 steps. Start by adding an events property to user. Give it a one-to-many annotation. This looks just like the many-to-one annotation we used inside event. Except for the extra map by property, which tells Doctrine which property inside event this maps to. Second, now that we have the one-to-many, you also need to go to event and add an inverse by option pointing back to the event's property on user. I broke this onto multiple lines only to make things more readable. Finally, in user, create a construct method and set the event's property to a special array collection object. In a perfect world, the event's property would just be an array of event objects. But for Doctrine to work its magic, we need it to be an array collection object instead. But no worries, this object looks and feels just like an array, so just think of it like one. Complete things by adding the getter and setter for the events property. Now try the play script. It works! And we see both event names, since Wayne owns both of them. Behind the scenes, Doctrine automatically queries for the 2 event objects owned by this Wayne dude and puts them on the event's property. Notice that we didn't have to make any database schema changes for this to work. That's really important, because adding this side of the relationship is purely for convenience. Our database already has all the information it needs to link users and events. The one-to-many side of a relationship is always optional, and called the inverse side. If you need the convenience, add it. If you don't bother with it. The many-to-one side of the relationship is where the foreign key actually lives in the database, and it's known as the owning side. You'll always need to specify the owning side of a relationship. The inverse side is special for another important reason. If we called set events on a user and saved, the new events would be ignored. Only the owning side of the relationship is used when saving. For example, in create action of event controller, we're currently calling set owner on event. This is perfect because owner coincidentally is the owning side of the relationship. In a many-to-one and one-to-many association, the owning side is always the singular side. We are talking about one owner, so it's the owning side. If instead we decided to call set events on the user, we'd be setting the inverse side, and Doctrine would completely ignore it. In fact, let's just remove set events from users so that nobody calls this method on accident. The problem of not being able to set the relationship from both sides can be particularly tricky when working with a form that embeds many subforms. If you run into this, check out the cookbook entry on the topic at Symfony.com. Also, check out the reference manual for the collection form type. I want to show you a little bit of Doctrine magic by using an open source library called Doctrine Extensions. The first bit of magic we'll add is a slug to event. Not the Jabba the Hutt variety, but a property that is automatically cleaned and populated based on the event name. Head over to kmpbundles.com and search for Doctrine Extension. The Stoff Doctrine Extensions bundle is what we want. It brings in that Doctrine Extensions library and adds some Symfony glue to make things really easy. Click into its documentation. Installing a bundle is always the same 3 steps. First, use Composer's require command and pass it the name of the library. If it asks you for a version, type ~1.1.0. In the future, Composer should decide the best version for you. Like we've seen before, the require command just added the library to composer.json for us and started downloading it. Second, add the new bundle to your app kernel. And third, configure the bundle by copying a few lines from the README. All of the details on how to install a bundle and configure it will always live in its documentation. This bundle brings in a bunch of cool features, which we have to activate manually in config.yaml. The first is called Sluggable. Open up the event entity and add a new property called Slug. This is just a normal property that will store a URL-safe and unique version of the event's name. And now let's add the getter and setter. Ready for the magic? Let's see if we can get the slug field to be automatically populated for us, based on the event's name. The Staff Doctrine Extension bundle is actually just a wrapper around another library called Doctrine Extensions that does most of the work. We can go to its README to get real usage details. Find the Sluggable section and look at the first example. This library works via annotations, so copy and paste the new use statement into event. Next, copy the annotation from the slug field and change the field's option to only include name. This says that we want Doctrine Extensions to automatically set the slug field based on the name property. If we also set updatable to false, it tells the library to set slug once and never change it again, even if the event's name changes. That's good because the slug will be used in the event's URL, and changing URLs is lame. Okay, let's try it. Update the database schema. This explodes because our existing events will all temporarily have blank slugs, which isn't unique. Drop the schema and rebuild from scratch to get around this. Reload the fixtures and check the results by querying for events via the console. Hey, we have slugs! That's not something you would be excited about outside of programming. As an added bonus, if two events have the same name, the library will automatically add a -1 to the end of the second slug. The library has our back and makes sure that these are always unique. We've got slugs! So let's enjoy them by putting them into our URLs. First, change the event show route to use the slug instead of the ID. You can also update the other routes if you want to, but this is the most important URL to get right. Update the show action accordingly and query for the event using the slug. And with those two small changes, this page should work. Head over to the homepage to try it. Ah, a huge error. The event show route now has a slug wildcard instead of ID. So wherever we're generating a URL to this route, we need to change the wildcard we're passing to it. I'll use the git grep command to figure out where we're using this route. Update each to pass in the slug instead of the ID. refresh the homepage. Nice! When we click on an event, we have a beautiful URL. Let's do more magic. I always like to have created at and updated at fields on my database tables. A lot of times this helps me debug any weird behavior I may see in the future. The Doctrine Extensions library does this for us. It's called timestampable. Enable it in config.yaml. Head to the timestampable section of the documentation to see how this works. We already have the Gedmo annotation, so just copy in the created and updated properties and rename them to created at and updated at. Just because, well, I like those names better. And now we'll generate getter methods for these. We can also add setter methods if we want, but we don't need them. The library will set these for us. Next, update the database schema to add the 2 new fields and then reload the fixtures. Query for the events again. Nice! Both the created at and updated at columns are properly set. To avoid sadness and regret, add these fields to almost every table. Okay, friends, the homepage lists every event in the order they were added to the database. We can do better. Head to Event Controller and replace the Find All method with a custom query that orders the events by the time property, so that we'll first see the events that are coming up next. When we check the homepage, it looks about the same as before. Let's complicate things by only showing upcoming events. This uses the parameter syntax we saw before and uses a /datetime object to only show events after right now. To test this, edit one of the events and set its time to a date in the past. When we head back to the homepage, we see that the event is now missing from the list. This is great, but what if we want to reuse this query somewhere else? Instead of keeping the query in the controller, create a new method called getUpcomingEvents inside Event Repository and move it there. Now that we're actually inside the repository, we just start by calling createQueryBuilder. In the controller, continue to get the repository, but now just call getUpcomingEvents to use the method. Whenever you need a custom query, create a new method in the right repository class and build it there. Don't create queries in your controller. Seriously. We want your fellow programmers to be impressed when you show them your well-organized Jedi ways. I want you to attend my event, so you're going to need to be able to RSVP. First, think about how this would be stored in the database. One user should be able to attend many events, and one event will have many attendees. This is a classic many-to-many relationship between the event and user entities. We already added a many-to-one relationship earlier, and adding a many-to-many will be very similar. To model this, create a new attendees property on event that'll hold an array of users that can't wait to go. Like with the many-to-one, we just need an annotation that tells Doctrine what type of association this is and what entity it relates to. Whenever you have a relationship that holds multiple things, you need to add a construct method and initialize it to an array collection. We saw this on the user events property earlier when we added the one-to-many association. Next, we'll add a getter method only. I'll explain why the setter isn't needed in a moment. And that's it. Let's dump the schema update to see how this will change our database. Doctrine is smart enough to know that we need a new join table that has event ID and user ID properties. When we relate an event to a user, it'll insert a new row in this table for us. Doctrine will handle all of those ugly details. Rerun the command with --force to add the table. With the many-to-many, you can optionally add a join table annotation. Add this only if you want to customize something about the join table. For example, you can control the onDelete behavior that happens if a user or event is deleted. Run the Doctrine Schema Update command again. Actually, no changes are needed. Doctrine uses this onDelete behavior by default. Let's put our new relationship into action. Create two new routes next to our other event routes, one for attending an event and another for unattending. Next, hop into the event controller and create the two corresponding action methods. Start with attend action. The logic here should feel familiar. First, query for an event entity. Next, throw a create not found exception if no event is found. All we need to do now is add the current user object as an attendee on this event. Remember that the attendees property is actually an array collection object. Use its add method, then save the event. Finally, redirect when you're finished. Notice that we just added an attendee without needing a setAttendees method on event. This works because attendees is an object, so we can just call getAttendees and then modify it. Before we try this out, let's update the event show page. Use the length filter to count the number of attendees. You know, to make sure we make enough guacamole. We can even loop over the event attendees and print each of them out. Print a nice message when nobody's attending, using Twig's really nice for-else functionality. Now, help me add a link to the new event attend route if the user is logged in. Head over to an event in your browser. It says 0 attending. Now click the new link. After the redirect, we see 1 attending. But we also see a huge error. The fact that we show one attending means that the database relationship was stored correctly. We can prove it by querying for the join table. Yep, we see one row that links our user to this event. So what's the error? Look closely. PHP is trying to convert our user object into a string. This is happening because we're looping over event attendees, which gives us user objects that we're printing. We have two options to fix this. First, we could just print out a specific property on the user. But if you do just want to print the object, you can add a toString method to the user class. Refresh now. Sweet, no errors. Let's also take a second and fill in the number of attendees on the index page. Now click the Attend link again. An error. Our user is once again added as an attendee to the event. And when Doctrine saves, it tries to add a second row to the join table. Not cool. To fix this, create a new method and event called hasAttendee. This will return true or false depending on whether or not a given user is attending this event. Find Attend action in Event Controller. We can use the new hasAttendee method to avoid adding duplicate users. Try it out. Go crazy. Click the Attend link as many times as you want. You're only added the first time. Let's fill in the logic and unattend action. Actually, we can just copy Attend action and remove the current user from the attendee list by using the Remove Element method. In our show template, let's show only the attend or unattend link based on whether we're attending the event or not. That's easy with the hasAttendee method. When we refresh, the Unattend button is showing. Click it, and then click the Attend button again. This bake sale is going to be off the hook. Quickly, look back at the redirect and generate URL methods we're using in our controller. Let's see what these really do by opening up Symfony's base controller class. Like we've seen over and over again, generate URL is just a shortcut to grab a service from the container and call a method on it. The redirect method is even simpler. It returns a special type of response object that's used when redirecting users. The point is this: Symfony is actually pretty simple under the surface. Your job in every controller is to return a response object. The container gives you access to all types of powerful objects to make that job easier. Yeah, we can RSVP for an event, but it's not super impressive yet. You and I both know that a little AJAX could spice things up. Our attend and unattend endpoints aren't really ready for AJAX yet. They both return a redirect response, which really only makes sense when you want the browser to do full page refreshes. So why not return something different, like a JSON response? JSON is great because it's easy to create in PHP and easy for JavaScript to understand. And actually, could we make the endpoints return both? Why not? Start by adding a format wildcard to both of the routes. Give it a default value of HTML. As soon as we give a wildcard a default value, it makes it optional. For us, it means that we can now go to /5/attend.json, but /5/attend still works too. So if the format part is missing, the route still matches. In a truly RESTful API, it's more correct to read the accept header instead of putting the format in the URL like we're doing here. If you're interested in that, check out our REST series. It'll blow your mind. I don't really feel like also making the endpoints return XML, so let's add a requirements key to the route. Now try to go to the URL with .xml in the end. The route doesn't match. Requirements are little regular expressions that you can use to restrict any wildcard. With this new wildcard in our route, we can now use it to return JSON or a redirect response. You know what the next step is. Give attend action a format argument. If it's equal to JSON, we can return a JSON string instead of a redirect. How? Just create an array and then convert it to JSON with JSON encode. And do you remember the cardinal rule of controllers? A controller always returns a Symfony response object. So just create a new response object and set the JSON as its body. It's that simple. Stop overcomplicating it. Test it out by copying the link and adding .json to the end. Hello, beautiful JSON. If you go to the Network tab of your browser's tools and refresh, you'll find an ugly surprise. Our response has a text/HTML content type. Silly browser. Okay, this is our fault. Every response has a content type header, and its job is to tell the client if the page is text/HTML, application/JSON, or text/turtle. Yeah, that's a real format. It's actually XML, so not as cute as the name sounds. Anyways, it's our job to set the header, which defaults to text/HTML in Symfony. Use the headers property on the response to set it. All right, refresh again. A beautiful application/JSON content type. Okay, so there's an even lazier way to do this. Throw on your sweatpants, grab that bag of chips, and let's get lazy. Instead of response, use a class called JSON_response and pass it the array directly. Oh, and get rid of the content type header while you're in there. Refresh again. Yeah, we still see JSON and the content type header is still application/JSON. JSON response is just a subclass of response, but it removes a few steps for us, and I like that. Time to stop playing and finish unattend action. Just copy the logic from attend action, change the value to false, and don't forget the format argument. When we try it manually, it seems to work. Looking at these two methods, do you see any duplication? Yeah, just about every line is duplicated. We can fix at least some of this by creating a new private method called createAttendingResponse with event and format arguments. Copy in the logic that figures out which response to return. For the attending value, why not just use our hasAttendee method to figure this out? Sweet! Let's do my favorite thing. Delete some code. Call the new method in attend action and unattend action and return its value. We can use this function to easily generate the JSON response for both controllers. Try it out. Isn't it nice when things don't break? Stop. We haven't touched JavaScript yet. But because the attend and unattend endpoints can return JSON, our app is fully ready for some Ajax. The attend unattend button will be a lot cooler with it anyways, so let's add some JavaScript. I'll give both links a JS attend toggle class that we can look for in jQuery. Wait, we can't write jQuery without, including jQuery. So open up the base template and add it inside the JavaScript block. I'm just going to use a CDN. To add JavaScript on just this page, we can override this block and call the parent function. I'll paste in some jQuery magic that makes an Ajax call when the links are clicked. You can get this magic from the attend javascripts.js file in the code download. I know, in a perfect world, this should live in an external JavaScript file. I'll leave that to you. Let's try our new Ajax magic. Ooh, fancy! The link disappears and we get a cute message. The code is simple enough. We listen on a click of either link, send an Ajax request, then hide the link and show a message. To get the URL, I'm using the href, then adding .json to the end of it. That's actually kinda hacky. There's a sweet bundle called FOS.js Routing Bundle that can do this much better. It lets you actually generate Symfony routes right in JavaScript. It's easy to use, so include it in your projects. Sometimes things fall apart, and when they do, we show our users an error page. Hopefully a hilarious error page. Right now our 404 page isn't very hilarious, except for the little Pac-Man ghost that's screaming, "Exception detected!" He's adorable. We see this big descriptive error page because we're in the dev environment, and Symfony wants to help us fix our mistake. In real life, also known as the prod environment, it's different. To see our app in its real-life form, put an app.php after localhost. We talked about environments and this app.php stuff in episode 1. If you don't remember it, go back and check it out. The page might work, or it might be broken. That's because we always need to clear our Symfony cache when we're going into the prod environment. Okay, now the site works. Invent a URL to see the 404 page. Ugh, gross. This error page isn't hilarious at all. So where's the content for this page actually coming from, and how can we make a better experience for our users? To find out, let's just search the project. In PHP Storm, I can navigate to vendor/symphony/symphony. Right-click, then select Find in Path. Let's look for the "an error occurred" text. Aha! It points us straight to a file in the core twig bundle called error.html.twig. Let's open that up. Cool, so how can we replace this with a template that has unicorns or pirates or anything better than this? There's actually a really neat trick that lets you override any template from any bundle. All we need to do is create a template with the same name as this in just the right location. This template lives in Twig Bundle and in an exception directory. Create an app, resources, Twig Bundle, views, exception, error.html.twig file. Notice how similar the paths are. It's the magic way to override any template from any bundle. Now just extend the base template and put something awesome inside. I'm going to abuse my login.css file to get this to look okay. I know, I really need to clean up my CSS. Refresh. Hey, don't act so surprised to see the same ugly template. We're in the prod environment. We need to clear our cache after every change. Refresh again. It's beautiful. The pain with customizing error templates is that you need to be in the prod environment to see them, and that means you need to remember to clear cache after every change. But we have a problem. This template is used for all errors, 404 errors, 500 errors, and even the dreaded 418 error. I think we should at least have one template for 404 errors and another for everything else. Copy the existing template and paste it into a new file called error404.html.twig. That's the trick, and this works for customizing the error page of any HTTP status code. We should keep the generic error template, but let's give it a different message. To see the 404 template, clear your cache and refresh again on an imaginary URL. To see the other template, temporarily throw an exception in event controller index action to cause a 500 error. Head to the home page, but with the app.php still in the URL. You should see that the servers are in fact on fire, which I guess is cool. Remove this exception before moving on. Behind the scenes, Symfony dispatches an event whenever an exception happens. We haven't talked about events yet, but this basically means that if you want, you can be notified whenever an exception is thrown anywhere in your code. Why would you do this? You might want to do some extra logging or even completely replace which template is rendered when an error happens. We won't cover event listeners in this screencast, but there's a cookbook called How to Create an Event Listener that covers it. Normally, when there's an exception, Symfony calls an internal controller that renders the error template. This class lives in Twig Bundle and is called Exception Controller. Let's open it up. The guts of this class aren't too important, but you can see it trying to figure out which template to render in Find Template. You can even see it looking for the status code version of the template, like error404.html.twig. I'm making you stare at this class because if you want, you can actually override this entire controller. If you do that, then your controller function will be called whenever there's an error and you can render whatever page you want. That process is a bit more involved, but use it if you need to go even further. When a user sees our 404 page, I'd love it if we could show them a list of upcoming events. But that's not possible. Normally I'd query for some events and then pass them into my template. But we don't have access to Symfony's core controller that's rendering error404.html.twig. Whenever you're in a template and don't have access to something you need, there's a surefire solution. Use the twig render function. This lets you call any controller function you want and prints the results. Start by adding a new controller function that queries for upcoming events and renders a template. So far, this feels like any other controller, except it doesn't have a route. Create the template and grab the event rendering code from index.html.twig. But hey, don't extend the base layout. This controller is meant to just render part of a page, not the entire HTML body. I also need to rename entities to events, since that's how I called the variable in the controller. The new controller prints just a list of events without a layout. We didn't give it a route, but we don't need to. We're going to call it straight from Twig. Oh, and what's up with the underscore in front of the name? That's just a standard I follow for controllers that render partial pages. Okay, now I'll show you the power behind this render weapon. Remove the query and index action and pass nothing into the template. Next, remove the big entities for loop that we just copied from index.html.twig and replace it with the render function. Try out the home page in the dev environment. Hey, it looks just like before. Render calls our controller, we build a partial HTML page, and then it gets printed. This handy function is great for reusing page chunks and is also key to using Symfony's caching. Our goal was to list upcoming events on the 404 page. Well, that's pretty easy now. Move to an imaginary page in your prod environment. In other words, put the app.php back in the URL. But don't forget to clear your cache. Great! Now, what if we wanted to show a different number of upcoming events on the home page versus the error page? No problem. Render lets us pass arguments to the controller function. Pass a max argument of 1 from the error template. Next, add a max argument to underscore upcoming events action. And give it a default value so that we don't have to pass it in. Send this variable into the getUpcomingEvents function. In Event Repository, give the function a max argument. Instead of returning immediately, set the query builder to a variable and then return it later. If max is set, limit the number of results that will be returned. Clear your cache and then try it out. Hey, only one event! Not only can render call a controller, but we can control its arguments. Now you are unstoppable. Buzzword time! Services, dependency injection container. Hold on, because we're about to discover what these terms mean, how core they are to Symfony, and just how simple these things really are. Pretend that someone needs to be able to download a CSV of all of the events that have been updated during the last 24 hours. Let's create a whole new controller class for this called Report Controller, since Event Controller is getting a bit big. Let's create an updated events action and use those handy annotation routes. And of course, don't forget to copy in the route use statement for the annotation. Try the URL in your browser. If you see the controller must return a response error like I do, then we're good. This is proof that our controller is being executed. First, we need a custom query to find recently updated events. Should we just put this in our controller? I hope you're screaming no. The force is strong enough in us to now put these directly in our repository class. Create a new getRecentlyUpdatedEvents method in Event Repository and build a query that only returns events updated within the last 24 hours. Let's call this in the controller. This should be getting boring because we always query the same way. Get the entity manager, get the repository, then call a method on it. Now, we need to turn these event objects into a CSV. I'll write some manual code for this. Yes, there are better ways to create CSVs, but trust me for a second. This code will help us show off one of Symfony's most powerful features. So what does a controller always return? A response object, of course. Let's just create one manually and pass the CSV content to it. Refresh. Gosh, that's the prettiest CSV I've seen all day. But if I check the Network tab in my browser, the response is text/HTML. I forgot to set that pesky content type header. Let's fix that. This time, Chrome sees that it's a CSV and downloads it for me. There's nothing new so far, but we're writing great code. Create a new reporting directory in the bundle and a new Event Report Manager class inside of it. Like any other class, give it the right namespace. But unlike entities, forms, and controllers, this class is special because it has absolutely nothing to do with Symfony. It's just a plain old PHP object that we'll use to help organize our own code. Create a getRecentlyUpdated report method to the class and paste the logic from our controller that creates the CSV text. To use it in Report Controller, create a new instance of Event Report Manager and call getRecentlyUpdatedReport on it. And hey, don't forget the use statement when referencing the class. So why am I making you do this? Remember how we put our queries in repository classes? That's cool because it keeps things organized and we can also reuse those queries. We're doing the exact same thing, but for reporting code instead of queries. Inside Event Report Manager, the reporting code is reusable and organized in one spot. But don't get too excited. I broke our app. Sorry. We're calling this getDoctrine. That function lives in Symfony's base controller. But in Event Report Manager, we don't extend anything. And we don't magically have access to this doctrine object. The code inside Event Report Manager is dependent on this doctrine object. Well, more specifically, it's dependent on Doctrine's entity manager. The fix for our puzzle is to inject the dependency or to use dependency injection. That's a very scary term for a really simple idea. First, add a constructor method with a single EM argument. Set that on a new EM class property. This will be the entity manager object. Inside getRecentlyUpdatedReport, use the new EM property and remove the non-existent getDoctrine call. Back in Report Controller, get the entity manager like we always do and pass it as the first argument when creating a new Event Report Manager. Refresh. Yes, the CSV has downloaded. You deserve some congrats. You've just done dependency injection. It's not some new programming practice or magic trick. It's just the idea of passing dependencies into objects that need them. For us, Event Report Manager needs the Entity Manager object. So when we create the manager, we just inject it by passing it to the constructor. Now that the manager has everything it needs, it can get its work done. And you know what else? We also just created our first service. Yes, we're hitting multiple buzzwords at once. A service is a term that basically refers to any object that does some work for us. Event Manager generates a CSV, so it's a service. So what's an object that's not a service? How about an entity? They don't really do anything, they just hold data. If you code well, you'll notice that every class fits into one of these categories. A class either does work but doesn't hold much data, like a service, or it holds data but doesn't do much, like an entity. Another common property of a service class is that you only ever need one instance at a time. If we needed to generate 2 CSV reports, it wouldn't really make sense to instantiate 2 Event Report Manager objects when we can just reuse the same one twice. Services are the machines of your app. Each does its own work, like creating reports, sending emails, or anything else you can dream up. One more buzzword, the service container, or dependency injection container. The service container is the benevolent overlord that's behind everything. He doesn't do any work, of course, but he controls all the little peons, or services. The container is just a simple object that holds all of the services in your project, including Symfony's core objects. Run the container debug console task to get a list of these. This list is tiny, only about 200 or so. With such a tiny list, it's easy to spot the Entity Manager service. This is the name of the service, and we use it to get this object out of the service container. We've been getting the Entity Manager by using a helper function in the controller, but since we know its service name, we can get it directly. Refresh. The download still works. This is just a more direct way to access the same object. But stop. This is hugely powerful. Symfony's container holds over 200 services, and you can get any of these in a controller and use them. It's like someone just gave you 200 new power tools. You may not know how to use them yet, but you're about to look like Edward Scissorhands. I want to go further by adding our own service to the container. Find and open a services.yaml file that was generated automatically in Event Bundle. When you add a new service, you're teaching the container how to instantiate it. First, it needs to know what the class name is. The Event Report Manager is the internal name of the service and can be anything. The arguments key tells the container exactly what to pass to the constructor when it creates a new instance of our service. For example, if the first construct argument to Event Report Manager were a string, we could just type that value here. But instead of a string, the first argument to Event Report Manager is the Entity Manager service object. To pass in a service, just put its name here and prefix it with the magic @ symbol. The @ symbol tells the container that doctrine.orm.entityManager isn't a string. It's another object inside the container. When the container creates a new instance of Event Report Manager, it passes the Entity Manager to it. Rerun the container debug console command. Ooh la la, our new service is in the container. Get this new service in our controller. You already know how to get objects out of the container. We just did it a minute ago with the Entity Manager. It's exactly the same with our service. In Report Controller, remove the new call of the Event Report Manager and replace it with a call to the container object. Refresh. Bam! The CSV still downloads. Internally, Symfony creates a new instance of Event Report Manager and returns it. If we ask for the service a second time, the container would just give us the same instance as before, instead of creating a new one. That's nice for performance. Okay, back up and look at what we've just accomplished. By creating Event Report Manager and moving logic there, we made some of our code more organized and reusable. By going a step further and registering a service, we made it even easier to get and use this object. The services on the container are your application's tools, and you'll add more and more. Let's do a little digging where we shouldn't. Go into the app cache dev directory where Symfony stores its cache files. In here, there's a file called app-dev-debug project-container.php. Open it up. This is actually the container class. When you say this container in your controller, you're getting back an instance of this object. Search for the getEventReportManager service function. Internally, when we ask for our service, this is the code that's run. It's not magic. It's just running the exact same PHP code that we had in our controller before registering our class as a service. If we made a change to services.yaml and refreshed, Symfony would update this file. Pretty amazing. So just like with routing files, services.yaml isn't magically loaded by Symfony. Something needs to import it. When the bundle was generated, an event extension class was created for you. This class is mostly useful for third-party bundles, but one thing it does by default is load the services.yaml file. If you don't have this extension class in your bundle, no problem. In fact, delete the entire dependency injection directory. Now just import your services.yaml file from inside config.yaml. You could also rename services.yaml to anything else. As you can see, the name isn't important. Refresh. More CSV downloading! There's one more thing in our service that's bothering me. The first argument to the constructor is the entity manager object, but we're not type hinting it. Type hinting is optional, but I like doing it because it gives me better errors and gives me auto-completion in PHP Storm. So what is the class for the entity manager service? One way to find out is to use container debug, but pass it the service name. It says that it's just an alias for a different service, so let's look up that one. Great! Now we can add a type hint for the argument. And by the way, a lot of times I just guess the class name and let PHP Storm mind trick. I mean, autocomplete the use statement for me. It's lazy, but it almost always works. If you're not too comfortable with this, don't worry. This is optional, but a good practice to get into. The CSV returns the ID, name, and time of each event. Let's pretend that someone is using this to double-check the accuracy of updated events. To make their life easier, I want to also return the URL to each event. So how do we generate URLs? In Event Controller, we use the generate URL function. So let's try putting that into Event Report Manager and seeing what happens. Let's try it. No download, just an ugly error. We made this mistake before. Generate URL lives in Symfony's controller, and we don't have access to it here. Open up that function to remember what it actually does. This tells me that if I want to generate a URL, I actually need the router service. So how can we get the router service inside Event Report Manager? You know the secret. Dependency injection. Add a second constructor argument and a second class property. This time, I guess the router class name for the type hint. Now that we have the router, just use it in the function. Okay, let's test it. Great! Now we get a different error. Read it closely. It says that something is calling construct in our class, but passing it nothing for the second argument. Of course! We forgot to tell the container about this new argument. Open up the services.yaml file and add a second item to arguments. Now we get the download again. Open up the CSV. Hey, we have URLs. Whoops, the URLs aren't helpful unless they're absolute. Pass true is the third argument to generate to make this happen. Download another file. Now let's open it up. Perfect! Here are the huge takeaways. When you're in a service and you need to do some work, just find out which service does that work. Inject it through the constructor, then use it. You'll use this pattern over and over again. Understand this, and you've mastered the most important concept in Symfony. We know services, and that makes us really dangerous. Let me show you one of your new tricks. Twig gives us a ton of built-in functions, filters, tests, and other goodies. Everything in Twig, like the path function, the upper filter, and even tests like divisible by are loaded into Twig by extensions, which are basically Twig plugins. So, can we add our own custom Twig stuff? Of course we can, and it's really fun. Create a Twig directory inside Event Bundle and add a new class called Event Extension. The name and location of this class aren't important, and you'll see why. Make the new class extend Twig extension and add the required getName method. This isn't important. Just make sure getName returns something unique to your project. The mission, if you choose to accept it, is to create an ago filter, something that'll turn a date into a friendlier phrase like 5 minutes ago. In upcoming events.html.twig, add a new line that takes the created at time of each event and pushes it through this imaginary ago filter. To add the filter, create a new method called getFilters and return an array with a single ago entry. This says, hey, whenever someone uses an ago filter in Twig, call a calculateAgo function. Create that function and give it a datetime argument. To do the heavy lifting, I'll use a dateUtil class that I have in the code download. Create a new util directory and paste it there. Inside Event Extension, just call this function statically and return it. Okay, try going to the home page. It says the filter still doesn't exist. We have created a valid Twig extension with the filter, but we haven't actually told Twig about it. Services to the rescue! First, create a new service for our Twig extension. Hey, this looks familiar. The only difference is that arguments is empty because we don't even have a constructor in this case. At this point, our Twig extension is a service, but Twig still doesn't know about it. Somehow, we need to raise our hand and say, hey, Symfony! Hey, Symfony! This isn't a normal service, it's a Twig extension. Add a tags key with a funny-looking twig dot extension below it. You know how a blog post can have tags? The idea is the same here. When Symfony boots, Twig looks for all services with a twig dot extension tag and includes those as extensions. Refresh. The new posted text looks fantastic. If you want this functionality in real life, check out the K&P Time Bundle, which is even more powerful. What other tags are there? Well, I'm so glad you asked. In the reference section of the docs, we have a fantastic page called the Dependency Injection Tags. If you're doing something really custom or awesome in Symfony, you're probably using a dependency injection tag. You won't use them too often, but they're key to unlocking really powerful features. A very important tag is kernel.event_listener, which allows you to register hooks inside Symfony at various stages of the request lifecycle. That topic is for another screencast, but we'll cover a very similar subject next: doctrine events. Remember when we used Stoff doctrine extensions to set the event slug for us? That magic works by leveraging one of the most powerful features of doctrine: events. Doctrine gives us the flexibility to have hooks that are called whenever certain things are done, like when an entity is first persisted, updated, or deleted. Open up Event and remove the @gedmo annotation above created@. Let's see if we can set this ourselves. Replace this with a new function called prePersist that sets the value. Hey now, don't get too excited. This won't work yet. But if we could tell Doctrine to call this before inserting an event, we'd be golden. The secret is called lifecycle callbacks, a fancy word for a function that Doctrine will call when something happens, like when an entity is first inserted. To enable lifecycle callbacks on an entity, add the has lifecycle callbacks annotation. Now just put a prePersist annotation above our function. PrePersist is called only when an entity is first inserted, and there are other lifecycle events like pre-update and pre-remove. Cool, let's give it a test. Reload your fixtures and then query to see the events. The created @ column is set, so this must be working. Lifecycle callbacks are brilliant because they're just so easy to set up. But they do have one big limitation. Because the callback is inside an entity, we don't have access to the container or any services. This wasn't a problem here, but what if we needed to access the router or the logger? The solution is to use a slight spin on lifecycle callbacks: events. In episode 2, we created a registration form and manually encoded the user's plain text password before persisting it. We even duplicated this logic in our fixtures. Shame! Our goal is to encode the user's password automatically using a Doctrine event listener. These are exactly like lifecycle callbacks, except that the function that's executed lives outside of your entity and inside some other class. Do you think this other class will be a service? Of course it will. Since I love classes so much, create one called User Listener in a new Doctrine directory of User Bundle. We're going to register this as a service, so the name and location don't matter at all. Add a prePersist method. To prove that this is called, just add a die statement. Next, let's register this as a service. We don't already have a services.yaml file in User Bundle. Technically, we could just register this in services.yaml in Event Bundle, but to keep things organized, create a new file in User Bundle and configure the service there. If you think Symfony is going to automatically find this file, you're nuts. Import it manually from your main config.yaml file. Just like with the Twig extension, our listener is a service, but Doctrine doesn't automatically know about it. Let's use another tag, this time called doctrine.eventListener. The name says we're a listener, and event tells Doctrine which event we're listening to. When Doctrine loads, it looks for all services tagged with doctrine.eventListener, and makes sure that those services are notified on whatever event is specified. It's the moment of truth. Reload the fixtures. Yes, our die function is hit. To encode the password, copy in the encode password from our user fixtures and rename it to handle event. I'll also make a few other changes, like getting the plain password value off of the plain password property and setting the encoded password on the user. This function is almost ready. Whenever Doctrine calls prepersist, it passes us a special lifecycle event args object. Add an argument for this. We can use this to get the actual object being saved. If that object is an instance of user, then we know we want to act on it. If anything else is being saved, we'll just ignore it. This is important because the function is called when any entity is saved. We're almost done. You've probably already noticed that the this container line won't work here. We don't have a container property. That's something special to controllers and a few other places. Again, not a problem. The listener ultimately needs the security.encoder factory service. So let's just inject it. Add a constructor with this as the first argument. Use the new property in handle event. The listener is perfect. The last step is to tell the container about the new constructor argument in services.yaml. We're ready. Remove all the encoding logic from load users and just set the plain password instead. Reload the fixtures again. Whoa, no errors. Okay, let's log in. Hey, that works too. As long as a new user has a plain password, our listener will automatically handle the encoding work for us. With this in place, remove the encoding logic from register controller. But what if a user updates their password? Our listener isn't called on updates, so the encoded password can never be updated. Crap. Add a second tag to services.yaml to listen on the pre-update event and create the pre-update method by copying from prepersist. Add a die statement so we can test things. Also, if the plain password field isn't set, don't do any work. This will happen if a user is being saved, but their password isn't being changed. We can't test this easily because we don't have a way to update users yet. No worries, just open up the play script from episode 1. We already have a user here. Just change his plain password and save. Okay, run the play script. It didn't hit our die statement. Our listener function wasn't called. It's a gotcha. The plain password property isn't saved to Doctrine, but we do use it to set the password field, which is persisted. The problem is that when we change only the plain password field, the user looks unmodified to Doctrine. So instead of calling our listener, it does nothing. To fix the issue, let's nullify the password field whenever plain password is set. Since password is persisted to Doctrine, this is enough to trigger all the normal behavior. Our listener should make sure password is set to the encoded value and not left blank. Now run the play script again. It hits the die statement. Remove that and try it again. No errors. So let's try to log in. Yes! We just saw pre-persist and pre-update. And Doctrine has several other events you can find on their website. Symfony also has events, which are fired at different points during the request handling process. Fortunately, Symfony's event system is very similar to Doctrine's. Don't you love it when good ideas are shared? You're awesome. Seriously, this was probably the most important episode yet, and you made it. Congrats! The first big piece included the two main Doctrine associations, many-to-one and many-to-many. We saw how each can have an optional inverse side, like the one-to-many side of many-to-one. The second huge piece was services, how they work, and how to create our own. A service is nothing more than a class that does some work. By putting our logic into a service, it makes it reusable, organized, and easier to unit test. When we register a service with Symfony, we teach it how to create a new instance of our object so that we have the convenience of simply getting it out of the container. We also saw a few tags and how you can use them to tell Symfony that your service should be used in some special way. So what's next? There's always more to learn with Symfony, but we've touched on almost all of the most important things by now. In the next and final screencast in this series, we'll talk about assets, aesthetic, form customizations, and finally deployment, and some performance notes. See you next time!